this question, we have the circular plate of radius 2r, and then we have this hole that is cut out of it, but this hole is not cut in the center. The center of the hole is a distance 0.8r from the center of the larger circle. So we want to know what is the center of mass of this plate. Hint is try subtraction. So what we can do is, usually we know for center of mass, what we do is, if we have two masses m1 and m2, the center of mass can be calculated as m1 x1 plus m2 x2 over m1 plus m2. So this is how we usually calculate the center of mass. But here, what we have, we do not have the addition of two masses m1 and m2, we have the subtraction. We have a part that is removed from a larger piece. And the interesting thing that we can do is we can actually try subtraction. What does that mean is we can first consider a disk that is 2r. So this is a round disk without any holes in it. And then we can think of it as we have a hole of radius r and with negative mass. So if you consider the superposition of a positive mass of radius 2r and a negative mass of radius r, and you superpose them, then you will end up with a configuration like this, like the one in the figure. Because the part when they superpose is positive mass plus negative mass equals 0, which is a hole. So this is what this question wants us to do. So we will be considering this hole as a different mass with the center of mass 0.8r from the center of this 2r disk, but with a negative mass. So let's start doing it. We have x equals, I will call this A and I will call this B. MA, XA, subtract MB, XB over MA minus MB. So I'm just changing all the plus here into a minus because I'm assuming MB is equivalent to treating MB as a negative value. So we want to position from, what is the position of the center of mass? So we will treat the origin as here, as C as origin. Because of that, MAXA can be ignored because XA equals 0. So all we have is negative MBXB over MA minus MB. So how do we find the relationship between MA and MB? We know MA equals, it's the same material, so it's rho times the volume. So it's 4 pi square r, that's the area of it, times random thickness, I'll just call it d. It will be the same for both of them, so it will cancel anyway, times rho. And MB equals pi r squared. Pi r squared times d times rho. So because of it, we can see that MA equals 4 times MB. Okay, so now we can try to calculate it. MB is negative MB times XB is 0.80r, and MA is 4 times MB minus MB. So it is negative 0.27r. So this is the center of mass of this whole piece. It is negative. What does it mean? What does that mean is that because we assume this 0.8r to be positive, so this is our positive direction. So a negative value means the center of mass is actually, it's somewhere on the other side. It's somewhere here. And that is to be expected because the hole is a little bit to the right of the center of the circle, so we would expect the left side to be a little bit heavier than the right side. So the center of mass should be a little bit more to the left. Yes, so that is the value we get. The center of mass of the shaded part is to the left of the center of the circle by 0.27 R.